everyone. I'm Dr. Rizwana, working as Professor of Physics in Institute of Aeronautical Engineering. Today, we are going to discuss some numerical problems in fiber optics. In my previous sessions, I have discussed in detail about fiber optics technology. So we have discussed about the construction principle, types of optical fibers, and then attenuation, and then advantages in optical fiber communication systems. So all that we have discussed. Now we are going to solve some problems, numerical problems, for the benefit of the students, for them to prepare for their exams. So we are going to start now solving those numerical problems. Frequently asked questions for examinations. So for the sake of students, we are going to discuss these numerical problems. Now, these are the problems in fiber optics. Coming to these problems, first problem given, calculate the refractive indices of core and cladding of an optical fiber with a numerical aperture of 0.33 and their fractional differences of refractive index 0.02. What is given here? We know that for an optical fiber, data given is numerical aperture. So what is numerical aperture of an optical fiber? Numerical aperture of an optical fiber is light gathering capacity, and it is numerically equal to sine of acceptance angle. So numerical aperture is given as sine of acceptance angle. And what is the formula for numerical aperture? Numerical aperture, it is given in terms of refractive index of core and cladding as n1 square minus n2 square. n1 square minus n2 square. So that value is given. So value of and also here, suppose if your launching medium is not air medium, then we have to take into consideration medium, outside medium, launching medium, and it is given as N0. So what is N0? N0 is the launching medium, and usually it will be air. And suppose if you are keeping your optical fiber in water, then the launching medium is going to change. And of course, N1 is refractive index of core and N2 is refractive index of cladding. And always we have to maintain N1 greater than N2. So what is the data given in this problem? Data given is numerical aperture. So what is the value of numerical aperture? It is 0.33. And then next, fractional refractive index change. So value of fractional refractive index is given. What is fractional refractive index change? So we know that this is fractional refractive index change. It is given as a ratio. And what is the ratio? It is the ratio between difference between refractive index of core and cladding to the refractive index of the core. So difference between refractive index of core and cladding to the refractive index of core itself. Okay. So this is our fractional change in refractive index. That value is given. And what is that value given? That value it is given as 0.02. So here this value it is given as 0.33 because in this case he is not talking about any launching medium. We have to consider it as air. And we know that for air, refractive index value it is equal to 1. Okay. And what is he asking us to find? He is asking us to find refractive index of core, that is N1. And also he is asking us to find refractive index of cladding, which is N2. So what is the data given? Data given is numerical aperture. And he has given fractional change in refractive index. This is the formula for fractional change in refractive index. And then he is asking us to find refractive index of core and refractive index of cladding. Okay. So for that, first I'll make use and one more relation. See, this is the relation between numerical aperture and fractional change in refractive index. This is one more formula. So here for numerical aperture, there are two formulas. One completely in terms of refractive index of core and refractive index of cladding. And other formula, it is in terms of fractional change in refractive index, which is given by numerical aperture is equal to N1. N1 is refractive index of core into square root of 2 delta. What is delta? Delta is fractional change in refractive index. So using this formula, I'll try to find refractive index of core. So refractive index of core, it is given as NA is our numerical aperture divided by using this formula, I got this relation square root of 2 delta. Delta is our fractional change in refractive index. I think both these values are given in the problem. So what is the value of numerical aperture? Numerical aperture is 0.33 as it is given. And of course, this fractional change in refractive index value is also given. If I make these substitutions in this formula, I'll end up having refractive index of core as 1.65. Okay. So in order to find the refractive index of core, I am making use of this formula for numerical aperture, which is given as n1 square root of 2 delta, where n1 is refractive index of core and delta is fractional change in refractive index. Then next, numerical. Now what else we need to find? We got value of refractive index of core. Now we have to find refractive index of cladding. In order to find refractive index of cladding, now I am making use of this relation for numerical aperture. So this relation I have used in order to find refractive index of core. Now this relation I am using in order to find the refractive index of cladding. And what is the formula? Na is equal to square root of n1 square minus n2 square. Now if I rearrange the terms, I'll end up having n2 square. What is n2 square? Square of refractive index of cladding equal to square of refractive index of core minus square of numerical aperture. So minus square of numerical aperture. Now n2, it is equal to square root of n1 square minus na square. What is n1? n1 is 1.65. And what is numerical aperture value given? 0.33. And if I simplify it, I end up having this 1.65 whole square as 2.7225 minus. And what is the square of numerical aperture? 0.1089. And if I take square root, I'll end up having refractive index of cladding as 1.54. So in this problem, what we have seen, if you are given data of numerical aperture and if you are given value of fractional change in refractive index, it is possible to find refractive index of core and cladding. And first, I think core I can find, because both are not given. I can find core refractive index using this formula, and I can find cladding refractive index using this formula. One more formula we can also use in order to find refractive index of cladding, because we know the value of n1 and we know the value of delta. Okay, so if we substitute in this formula value of delta how much? 0.02, and we know value of refractive index of core, refractive index 1.65 minus n2 by what is the value of n1? Again 1.65. Using this formula also we can find n2, and again n2 it comes out to be 1.54. This is another method. Once we know the value of delta and n1, we can use this method in order to find refractive index of the cladding. Okay, so we'll move to other numerical problem. Now if you consider this numerical problem, in this numerical problem I am given refractive indices of core and cladding. So what are the values of refractive indices of core? Refractive indices of core, it is 1.48 and refractive index of cladding is 1.45. I think you are observing that always n1 is slightly greater than n2. So, and that change between refractive index of core and cladding, it will be very small. See that difference. So, that change is only 0.03. So, it will be slight change in the refractive index. And core refractive index is given, cladding refractive index is given, it is given by n1 and this is given by n2. And he is asking us to find two parameters. What are those two parameters? First, he is asking us to find numerical aperture, and second thing, he is asking us to find acceptance angle. Okay, so now what is the formula we have to use? I think in our previous problem, we have used one relation for numerical aperture. What is that relation for numerical aperture? It is given by square root of n1 square minus n2 square. Okay, so in this formula, because already we know the formula of n1 and n2, and one more thing what I have to stress here is, because he is not talking about outside medium of optical fiber or launching medium of optical fiber. So here we have to consider our n0 to be 1. So we are considering that launching medium, outside medium to be 1. So that's why we end up having numerical aperture as square root of n1 square minus n2 square. So we know what is our n1. N1 it is already given, which is refractive index of core. It is given as 1.48 whole square minus what is n2. N2 is refractive index of cladding, which is given as 1.45 whole square. And if we simplify it, if we solve it, we end up having numerical aperture as 0.2965. So this is how we are going to find numerical aperture once we know the value of refractive index of core and cladding. Now, in order to find the acceptance angle, how to find acceptance angle? See, for acceptance angle, there are two formulas. Acceptance angle, it is given, first formula is, it is given as acceptance angle is equal to sine inverse of square root of n1 square minus n2 square by n0. This is one formula for finding acceptance angle. And second formula for finding acceptance angle is, we know that numerical aperture is sine of acceptance angle. We have this relation. This is also one more relation. So from this, I can have my acceptance angle as sine inverse of numerical aperture. So there are two formulas for finding. I can either make use of this formula or I can make use of this formula also. Okay, but because already have calculated numerical aperture value, I think we should go for second formula. In this formula, so acceptance angle, it is equal to sine inverse of numerical aperture. What is the value of numerical aperture? 0.2965. If I substitute here, I'll end up having my acceptance angle as 17 degrees 15 minutes. So if you want, like usually we'll get that value in degrees, so we can convert this into minutes. What is that conversion? So in order to convert this 15 minutes into degrees, I have to divide it by 60. 15 divided by 60, it will give your value in degrees. Otherwise, you can mention it in degrees and minutes. Okay. So what is the new formula we have used in this particular problem? When you are given refractive index of core and cladding, we can find using numerical aperture with this formula. And this formula, it is used in order to find acceptance angle once we know the value of numerical aperture. So now we'll go for third numerical problem. In this problem, what is the data given here? Data given is numerical aperture. What is the value of numerical aperture? 0.16. So value of numerical aperture is given 0.16, and refractive index of core is also given. What is the refractive index of core? It is 1.45. So data given is numerical aperture value 0, which is 0.16, and refractive index of core is 1.45. And what we are supposed to find here, we are supposed to find acceptance angle of the fiber and refractive index of the cladding. So we are supposed to find acceptance angle of the fiber and refractive index of the cladding. Okay. What is the data given? Numerical aperture value and refractive index core of value is given. Now, how to find acceptance angle and refractive index of cladding? So we'll make use of formula which we have discussed in the previous problem in order to find acceptance angle. What is that relation? Acceptance angle is sine inverse of numerical aperture, because numerical aperture is sine of acceptance angle. Because we are given value of numerical aperture in our problem, so we'll make use of this formula where acceptance angle is sine inverse of numerical aperture. What is our numerical aperture? 0.16. So sine inverse of 0.16, it is equal to, when we do it, when we simplify it, it comes out to be 9.206 degrees. If you want, you can convert this 0.206 degrees into minutes. Just if we multiply it with 60, we'll have it in minutes. So we can mention it in some degrees and minutes. Otherwise, we can mention it in degrees. So we have calculated our acceptance angle. Now, what else we need to find? We need to find refractive index of the cladding. What is the refractive index of cladding? N2. Okay. Now, what is the simplified method of finding N2 here? Because delta is not given. Suppose if delta is given, then because already we have N1, we can use formula delta is equal to N1 minus N2 by N1. Because delta is not given, so what is the appropriate formula which can be used in order to find numerical aperture? Our formula is numerical aperture is equal to square root of N1 square minus N2 square. So we are making use of this formula. Here also again our N0 is equal to 1. And if we rearrange the terms, so what we'll get here, n2 square is equal to n1 square minus square of numerical aperture. So n2 square. So from this we have n2 is equal to square root of n1 square minus numerical aperture whole square. So n2 is equal to square root of n1 square minus numerical aperture whole square. So we know the value of n1. What is our n1? n1 is 1.45 whole square and numerical aperture value is given as 0.16. So if I simplify it, what is the value of refractive index of cladding? 1.44. I think it's less than our core refractive index. Okay, so here what we have done, we have calculated acceptance angle and refractive index of the cladding. And what is the data given? Data given is numerical aperture value and refractive index of the core. So now we'll go for our next numerical problem. Coming to our next numerical problem. Here, what is the data given in this numerical problem? Here again, we are given the value of numerical aperture and we are given refractive index of cladding, which is equal to 1.59. And he is asking us to find acceptance angle for the fiber in water. So now he's mentioning, so what is the outside medium of the fiber? It is not air. So N0, it is not equal to air. It means that N0, it is not equal to 1. What is our N0? N0, it is water. And for water, what is the value of N0? He has given it as 1.33. So we have to take into consideration refractive index of outside medium. Okay, so but what is the data given? He has given the value of refractive index of water, launching medium, and this is our refractive index of cladding. He has given refractive index of cladding, which is 1.59, and also he has given value of numerical aperture. And what is he asking us to find? Acceptance angle. Okay, we don't know the value of N1. If we know the value of refractive index of core, then what is the formula which we have used in order to find acceptance angle? The formula is sine inverse square root of n1 square minus n2 square by n0. If we are given value of n1. What is missing? n1 we don't know. So we don't know n1. So n2 is given, n0 is given. Because we don't know n1, so we cannot use this formula. So what we have to do, what is the data given? Numerical aperture. Okay. So using this numerical aperture, we can find acceptance angle. What is the relation? What is the relation? Acceptance angle is sine inverse of numerical aperture. But here, acceptance angle we have to find in water. So that's why we have to take into consideration this total is our numerical aperture and we have to take into consideration our water medium in which we kept our fiber. So we have to take into consider this water medium. So that's why what is the formula to find acceptance angle? Formula is of course this one. Okay. So here what we can find here is, so what is the formula we are using in order to find acceptance angle? Acceptance angle is equal to sine inverse of numerical aperture divided by refractive index of water. Okay. So here already numerical aperture value is given. So it is sine inverse of 0.2 by 1.33. So if we do it, then we end up with having our acceptance angle as 8.65 degrees. This is our acceptance. There is a slight change in the problems what we have done previously. Here if outside medium is given, we have to consider this formula. We have to take into consideration this and not. So then we can have our acceptance angle. Okay, so suppose if nothing is mentioned about the outside medium, what is the medium outside? Then what we have to do, we have to consider it has to be the air and we have to take it to be 1. Because here is mentioning that it is in water. So that's why we have to make use of this formula. So acceptance angle is sine inverse of numerical aperture by n0. And of course, what is our numerical aperture? n1 square minus n2 square. So if you do it, our acceptance angle it is coming out to be 8.65 degrees. Again, we can write it in degrees and minutes also by converting this 0.65 degrees into minutes, just dividing it by 60. So this is our fourth numerical problem. Now coming to our last numerical problem. What is the data given? It is different from the problems which we have discussed in our previous problems. So here he is asking us to find fractional index change for a given optical fiber. So what is the fractional index change for a given optical fiber? Here we are talking about delta. Okay. So I think we have come across this particular term delta in our previous problems. And what is given? He has given refractive index of core as 1.563. And what is the refractive index of cladding? Refractive index of cladding, it is given as 1.498. Okay, so we need to find value of delta. I think formula for finding fractional change refractive index delta is this formula. I think already we are familiar. So delta, it is also called as fractional change in refractive index or fractional index change. So it can be called in either way. And how it is given? It is the ratio. And what is that ratio? In numerator, we have difference between refractive index of core and cladding to the refractive index of core. Okay, and we know what is the refractive index of core. Refractive index of core, it is given by 1.563, and refractive index of cladding is 1.498 divided by what is the refractive index of core? 1.563, and when we simplify it, we get this value as 0.0416. So in this particular fiber optics, so what are the different formulas we have used? So overall, what are the formulas that we have used in order to solve problems? First one, see, sometimes you will be asked to find even critical angle also. So critical angle, if you are given refractive index of core and cladding. So first problem, in order to find critical angle theta c. So what is our theta c? Theta c, it is called as critical angle. So if you take this critical angle theta c, how to find this critical angle? It is given as sine inverse of square root of refractive index of cladding to the refractive index of core. So this is the first formula. Okay. Second formula for finding acceptance angle. How we can find acceptance angle? So in order to find acceptance angle, so what are the formulas we can use? First is, in order to find acceptance angle I maximum, we got one formula in terms of refractive index of core and cladding as sine inverse square root of n1 square minus n2 square by n0, where n0 is refractive index of the launching medium. Okay, and then also how we can find the acceptance angle? There is one more formula. It is given as, okay, sine inverse of numerical aperture. If numerical aperture is given, we can find it as sine inverse of numerical aperture. So this is first problem and this is second problem. And coming to our numerical aperture, how we can find our numerical aperture? In order to find numerical aperture, there are two formulas. Okay. First formula is, of course, our square root of n1 square minus n2 square by n0, or simply our numerical aperture is sine of acceptance angle. And there is one more formula given for numerical aperture. What is that formula? It is given in terms of fractional change in refractive index. So what is that formula? N1 square root of 2 delta. So there are three formulas in order to find numerical aperture. First one is square root of n1 square minus n2 square by n0, and second one is numerical aperture is equal to sine of acceptance angle, and third one in terms of fractional change in refractive index is n1 square root of delta. What is delta? Fractional change in refractive index. And fractional change in refractive index or relative, it is also called relative refractive index change. Relative refractive index change or fractional change in refractive index. How it is given? Delta is equal to n1 minus n2 by n1. So based on these formulas, you will be given numerical problems and we have to select appropriate formula in order to solve that problem. And main thing what you have to observe here is, as I told you, if in the numerical problem, if refractive index of launching medium is not given, we have to assume refractive index of launching medium to be 1. Okay, and if they mention, like we have seen in our previous problem here, refractive index for launching medium or refractive index of the medium in which the optical fiber is kept, if it is given, then we have to take our n naught into consideration. So, but if nothing is mentioned about our medium in which the fiber is kept, then we have to take it to be the air medium. So, depending upon the data given in the numerical problem, we have to select our appropriate formula. So, with this, I'll come to end. So, we have discussed about different formulas based on which we can solve any numerical problem given in optical fibers. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.